The goal of this video for today is to demonstrate how to calculate the surface area of various three-dimensional figure. To start off, we have a rectangular prism. Notice how the word surface area asks us for surface. So first we have to count how many surfaces there are. There's 1, 2, 3, 4, 5, 6 total surfaces in this rectangular prism. Next, we're going to ask the next word in surface area, which is area, and we're going to count 1, 2, 3, 4, 5, 6, 7, 8. We got 8 4 times, so we have to take 8 and multiply it by 4. That accounts for the surfaces that are the rectangles here. Next, we have the 2 square at the ends, which is a 2 by 2, so that's 4. We have 4 times 2 because there's 2 of them. And when we add them all up, we have then calculate the surfaces in its area, hence the name surface area. Next, we move on to this rectangular prism, which is also called a cube. Here we have 3 by 3, which makes 9, and we have 1, 2, 3, 4, 5, 6. So we're going to take 9, because it's a cube and they're all squares. We're going to multiply it by, again, 1, 2, 3, 4, 5, 6. And that's how you calculate the surface area for this cube. Next, we have some irregular shapes. Sometimes you're going to have irregular shapes such as these, and they're going to want to ask you for the surface area. I'm going to pick 1 out of 3 for us to do right now. I want you to experiment doing the rest on your own with either using net or building the shapes themselves and counting all the surface in its area. So I'm going to put these two aside and we'll focus on this for now. So to use nets, remember that net is the unfolded if these were all unraveled out. So what I did was with a blank piece of paper, I traced the bottom. So here is my layout. I just plop it down to a base that I want. So this is my base, and I just traced that there was 5 squares. So I did 5 squares here. Now, notice in my front, so if this is my bottom, I have my front, which is 1, 2, 3, 4, 5, then up 1. So then I folded it down and then trace that exact shape, flip it back up to the base again. Did the same thing on the opposite side because there's 2 of them. Hence we have this shape, flat, side to side. Now we're going to walk the shape up, and it has 2 squares, right? But if I kept walking it over, on the bottom side, or in this case, on our top side, there's 5. 1, 2, 3, 4, 5. So I walked it over and I drew 5 more squares. Now I go back to my base again. If I go on the opposite side, if I actually go on the opposite side, I know you only land on 1, but you have to consider the fact that there's actually 2. Because let's look. Here is what I just turned to. If I turn it this way, notice how there's 1 and there's 2 here. So most people miss that second piece when they turn things over. So when I turned this over, I knew there was 2 because there's a missing space right here that needs to be drawn. So once I do that, I cut out and trace all the squares. You can do this on grid paper so you don't actually draw the squares, but I did it. And so I'm going to fold this up, and once it is folded up, it is going to look like this. So I put tape on a lot of areas just to keep it together. So again, I'm going to put it at my base, and I want to demonstrate that they are the same. So we got 5, 6, and 6 on the opposite side as well. On the top, you can see that there's 1, 2, 3, 4, 5. And then turn to the side, there's 2. And then on the opposite side, there's 2. So I have used the nets to make the 3-dimensional figure of the solid. And from there, you can unfold it and count the number of squares that it takes to get to that shape. Or you can, when you build a cube, count by hand that we have here. Notice that? Okay. So now let's count the squares. Again, we have 5 on the bottom, 6 on both sides. We got 2 on the side, 2 here, and then 5 here. So then you just add all of that up, and you should get, let's see, 1, 2, there's 3, 3, 3, 3. There is a 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. You're going to get a total of 26 squares. So that means the surface area of this shape is 26 square units.